Hey everyone, welcome back to another video. And in today's video, we'll be learning how to detect a person in an image using OpenCV in Python. In this video, I'll go through the entire code line by line, explain how it works, and also point out a mistake I initially made so you can learn from it and avoid it in your projects. By the end of this tutorial, you'll understand ORB feature matching, homography, and how to accurately highlight a person in a scene image. So without wasting any time, let's just get right into it. First, we need to import the necessary libraries. We import OpenCV and NumPy. OpenCV is the library that allows us to process and manipulate images, detect features, and draw on images. NumPy helps us work with arrays, which is essential because images are essentially arrays of pixel values. Next, we load the reference image, which is the image of the person we want to detect, and the scene image, which is the larger image where we want to find that person. Notice the 0 in the CV2 I am read. This tells OpenCV to load the image in grayscale. Grayscale images are easier and faster to process because we only have one channel instead of three, and feature detection works well on them also. Next, we also check if the images were loaded correctly. This is important because if the image doesn't exist in path or the file name is wrong, the code would crash otherwise. To make the images easier to process, we resize them. This also ensures that the reference image and scene image are not too large, which can slow down ORB feature detection. Here, reference image.shape gives the width of the reference image. We calculate a scaling factor so that the reference image's width becomes 300 pixels and the scene image width becomes around 600 pixels. We use cv2.interarea interpolation because it works well when reducing image size, maintaining clarity, and minimizing distortion. Now we create the ORB detector. Here's what's happening. ORB stands for Oriented Fast and Rotated Brief. It's a fast feature detector and descriptor extractor. KP1 and KP2 are the key points in the reference and scene images. Key points are distinctive points in the image like corners or edges. DES1 and DES2 are the descriptors. These are vectors that describe the key points so that we can compare them between images. The number 2000 in ORB create specifies the maximum number of features. To detect more features means more matches, but it also takes more computation time. After we have descriptors, we match them using a brute force matcher. cv2.normhamming is used because ORB descriptors are binary. KNN match find the two best matches for each descriptor. Next, we filter matches using Lowe's ratio test. This helps us remove false matches. We only keep a match if the distance or to the closest match is significantly better than the second closest match. Before drawing anything, we check if we have enough good matches to consider the person detected. If there aren't good matches, the person is not recognized. 10 is a threshold here. You can adjust it based on your images. If we have enough matches, we compute a homography to map the reference image onto the scene image. SRC points are the coordinates of matched key points in the reference image, while the DST points are the coordinates of the matched key points in the scene image. cv2.findHomography finds a transformation matrix M that maps the reference image points to the scene points. Ransack helps ignore the outliers so the mapping is more accurate. We then define the corners of the reference image and apply the homography to transform them onto the scene image. Now, DST contains the four corner points of detected person in the scene image. To draw a rectangle, we convert grayscale scene image to color. Then we calculate the rectangle coordinates. Here is the mistake I initially made. Notice that I used the wrong indices for y minimum and x maximum. This caused the rectangle to appear completely wrong. The correct code is this. Now, the rectangle correctly surrounds the detected person. We can also add a label. Finally, we display the image. If there weren't enough matches, we print this person not recognized. And we end the program by waiting for a key press and close all windows. So, to summarize, this code uses ORB feature detection, descriptor matching, and homography to detect a person in a scene. The main mistake I made was using the wrong indices when calculating the rectangle coordinates, but now it's fixed and the rectangle highlights the person accurately. Using this method, you can detect objects or people in images based on reference images, and it's a great way to understand feature-based matching in computer vision. So that was it for today's video. If you like the video, give this video a huge thumbs up and subscribe to the channel. Thank you so much for watching. Bye bye.